So for this problem, you're given a set of n item, and then you're given two integer arrays, values and labels. And they are used to store the first array is used to store the value of the item, and the second array is used to store the label of that item. So it's a case where the ith element of values I and labels I are used to store the value and the label of that item. And then you're given two extra integers, num wanted and use limit. So what you're asked to do is you're supposed to create a subset from the n items, where the number of items inside of that subset is always lesser than or equal to num wanted. And since you're taking values from them, you should ensure that so if two labels are the same, the use limit specifies the maximum number of values that could be in the subset that belong to the same label, and you're supposed to return the maximum score that could be for the subset. So yeah, it sounds a mouthful, but actually it's pretty simple. Essentially, they're asking us to create a maximum subset, and they're given some restrictions. So this problem is categorized as a common Google coding interview question. And I think the reason they make it ambiguous is to hopefully, to make sure the person or candidate is able to, have some technical understanding of the problem, where he takes down notes, asks clarifying questions, and based on the feedback is able to make adjustments to the problem. So yeah, to understand it, here they're given us a few examples. So given these two integer array, the first array represents the values and the second is the labels. So they're specified that the num wanted is 3. So you need to create a subarray where the maximum size is 3 and the use limit is 1, which means that items which have the same label. So here it's a case where 5 and 4 have the label 1. So we can pick only one item from each. So since it's 1, we just say 5. So that's the maximum item. Similarly, here we have 3 and 2 have the same label. We pick 3. And then finally we pick 1 because that's the only one available with the label 3. So yeah, we calculate that the maximum value that could be achieved is 9. So yeah, let's try. So given this problem, the best solution always involves using a priority queue data structure. So the advantage of that data structure is that it ensures all the values, or the maximum value will be saved at the top of the queue, and all insertion, deletion operation take place in logN time. So it's easy for us to, given a restriction, we can easily achieve which is the top, the maximum k items. So yeah, we'll just add a data structure, and we'll use another data structure, a hash map. So a hash map, the advantage is it has constant lookup time, and since they're given us a restriction that items with the same label, they cannot exceed the use limit, we can use that map to keep track of how many times we're using the item given that same label. So yeah, let's try coding the solution. First, we'll create the hash map and priority queue data structure. So hash. So this one is just to keep a count of how many values belonging to the same label is being added to the result. Next, the queue. So here we are saying the argument will be an integer array. This is because I think now we are going to retrieve the values from these two integer arrays and save them there. So we say pq is equal to new. So first thing, we initialize the hash map. So we'll add the label, and then we'll set the count to 0. And then we'll add the values to the priority queue data structures. So we just say values I. And now we'll define what's the manner in which we are going to sort the queue. So one of the way we can do it is during initialization is using a lambda function, where we just say that AB arrow mark, and then we say that sorted by the second index value of this integer array. So say B1 minus A1. So what it does is that now given we are adding this all the labels and values as an integer array into the queue data structure, they'll be sorted based on the value. So the ones with the largest value will be saved at the top of the queue. So after initializing it, yeah, let's create two variables to store the result. Spelling you and a count. So this is because they're given us a restriction that the value could not exceed num wanted. So we'll create a while loop. So now we'll keep removing values from the queue data structure. So pq.pull. So this one just keeps removing items from the top of the queue. So here we have specified that the label cannot exceed, the number of values from each label cannot exceed the use limit. So for that, we'll just make sure by checking the hash map. So hm.get num0 lesser than use limit. Then we start processing, else we do nothing. First thing we'll do is we'll keep adding it to the result. So result plus equal to 1. And then we'll increment the value in the hash map. So for that we just say num0 and we say num0 plus 1. So this value, essentially what it does is keeps incrementing the count in the hash map. So once it reaches the use limit, we keep ignoring it. Until then, we keep adding it to the result and incrementing it. Finally, we say return result. So yeah, quick recap. We're using the queue. We have specified the lambda function where we're using the second index to decide how the queue should be sorted. And then we add all the labels and values inside of that queue. And then we use a hash map to keep a count of how many times you're using values from each label. After that, we keep removing it from the queue and ensure that the number of times is lesser than the use limit. We keep adding the values to the result, incrementing the count, and we do it until either the queue is empty or we have reached the maximum count that we had. So yeah, it's pretty straightforward. Let's try running the solution. Oh, let me make a mistake. Missing bracket. So yeah, all the three use cases are passed. We'll try submitting it. So yeah, the time complexity will be O of nlogN. So where n is the number of items. So here it's a case where we keep adding it to the queue data structure. So like I said earlier, in a queue, all the insert deletion operation take place in log n time. So since we are first adding and then removing them, so it's 2 nlogN, which is, we can still say nlogN as the time complexity. For space, we are using a couple of data structures. Both of them will be of size O of n, because where n is the number of items. So one is to keep track of the labels, another is to just store the values in the queue, which will maximum size of the queue will be n. So we can say the space complexity is n. So yeah, let me leave comments. Let me know anyone has a better solution for this. And yeah, like and subscribe the video. I'm planning to add, I think, one video a day, depending on how busy I am. So hopefully I'm able to add more.